Morning, students. So what we have discussed in the previous class? Yes. So otherwise put it in the chat box somehow. So what we
Rolle's
have
theorem.
Rolle's theorem. Which problem we have discussed? Which problem we have discussed? So f of x equal to modulus of x. Is that problem discussed?
Yes, ma'am.
Okay. So what about this f of x equal to? So f of x equal to tan x. F of x equal to tan x. Yes, Sarah? So in the limits, here the limits are 0 to pi. So f of x equal to tan x in the limits 0 to 2 pi. And also all of you do this problem f of x equal to x cube in mine that is 1 comma 3, not minus 1, that is 1 comma 3. So in between the intervals 1 comma 3. So whether f of x equal to tan x is applicable or not, whether the Rolle's theorem is applicable.
No,
Yes, why?
Because it is discontinuous at pi by 2.
Yes. Okay. So f dash of x means that is nothing but tan x differentiation is secant square x, right? Okay. So is secant square x is differentiable at pi by 2? No, here you will get infinity. So that means f dash of x does not exist. So does not exist in between the intervals, does not exist in open interval 0 comma pi. Okay, so therefore Rolle's theorem is not applicable. Okay, Rolle's theorem is not applicable for the function f of x equal to tan x in open interval 0 comma pi or closed interval 0 comma pi. No issue. Okay. So what about this? Is this applicable? Is this function
No, ma'am.
for the Rolle's theorem? Why?
F of A is not equal to F of B.
F of A is not equal to F of B. So that means F of 1 is not equal to F of 3. Right? So that's why if one condition is failed, no, in that case that is not applicable. Okay. Okay, ma. So then all of you do this problem as a homework. So after that we'll start Lagrange's mean value theorem. Okay. So verify Rolle's mean value theorem for the function f of x equal to e power x sin x, not cos x, sin x minus cos x in pi by 4 comma pi by 4, in between the limits pi by 4 comma pi by 4. Okay. So next question is same, verify Rolle's theorem for the function f of x equal to x power 2 by 3 minus 2x power 1 by 3. So in between the interval 0 comma 8. Okay. And the last question is the function is x log x equal to 2 minus x. Okay, so the limits are 1 comma 2. So what is the function here? What is the function? F of x equal to x log x minus 2 minus x. Isn't it?
Yes, ma'am.
Otherwise, f of x equal to 2 minus x minus x log x. Okay. Is there any chance for this function? ఇంకా ఏమైనా ఛాన్సెస్ ఉన్నాయా? ఎలా రాసినా సేమ్. Okay, so but the limits should be positive limits. Okay, so because log x differentiation is 1 by x, if the limits is that means f dash of x does not exist where x equal to 0. Okay. Okay, all of you make a note of these 3 questions. All of you do these questions as homework. Okay. Now, so next method is Lagrange's mean value theorem. So before going to start Lagrange's mean value theorem, so when the functions will be applicable, when the functions are not applicable for the Rolle's theorem? Anyone, can you tell me? Yes, every polynomial will differentiable, right? And it is also continuous, and most of the cases if it is f of a equal to f of b. Okay, so first of all, main important thing is here we have to check whether it is differentiable or not. Okay, so every polynomial is differentiable, and e power x exponential is exponential function is also differentiable, right? Isn't it? What about trigonometric functions? What about trigonometric functions?
They are differentiable on their domain.
Only sine and cos are differentiable. So we need to check tan x, so cos x, sorry, cot x, secant x, and cosecant x. Okay, so you need to focus on only trigonometric functions. Those are like tan x, cot x, secant x, cosecant x, and also most important thing is here. All of you change your name as roll number. So first of all of you change your name as roll number. Make it fast. Pranita, change your name as roll number. Otherwise, I will remove you. Okay, so you should focus on trigonometric function and tan x and cot x, secant x, cosecant x, and also you should focus on log x. Okay, so in these cases, this is whether the function will be differentiable or not. That is totally depends on the limits. Okay. Now coming to the next method. So what is our next method? Lagrange's mean value theorem. So Lagrange's. So what is the statement of Lagrange's mean value theorem? Anyone, can you tell me? Lagrange's mean value theorem. Lagrange's mean value theorem. So in Lagrange's mean value theorem, same like Rolle's theorem, let f of x be a function such that first condition is it is continuous. It is continuous in closed interval a comma b, and second one is it is differentiable. It is differentiable in open interval a comma b. And what is the third condition?
F of A not equal to F of B.
No. Here we don't have any condition. Okay. So for that, so then there exists. Okay. Then there exists at least one point. At least one point. Yes. What is our next step?
F dash of C is equals to F of B.
Then there exists at least one point. C belongs to open interval a comma b, such that what is the main formula? F dash of C equal to, yes,
Minus F of A.
f of b minus f of a divided by b minus a. Okay, so this is our main formula. So this statement is also same like Rolle's mean value theorem, but here we don't have third condition. And the main formula is f dash of c. In that case, f dash of c equal to 0, right? But here f dash of c equal to f of b minus f of a divided by b minus c. Everything is same. So here also same, f of x be a function such that first one is it is continuous in closed interval a comma b. So always continuous will be exist in closed interval a comma b only. And differentiable, it is differentiable at open interval a comma b. Okay, so then there exists at least one point. C belongs to open interval a comma b, and the main formula is f dash of c equal to f of b minus f of a divided by b minus a. Okay, so here the main formula is different, everything is same. Okay, and in Rolle's theorem we have third condition, but in Lagrange's mean value theorem we don't have third condition. Okay, is it clear, all of you? Shall I erase my screen? Yes, what happened? Okay. So now coming to the first question, verify Lagrange's mean value theorem. Lagrange's mean value theorem for f of x equal to x cube minus x square minus 5x plus 3 in closed interval 0 comma 4. Okay, verify Lagrange's mean value theorem for the function f of x equal to x cube minus x square minus 5x plus 3. So how to do this problem? Anyone, can you tell me? Yes. So the given function is, yes, f of x equal to, first what we have to check here?
Continuous or differentiable?
Dash of
Yes, very good. Okay, so what is the statement of Lagrange's mean value theorem? So f of x be a function such that first condition is it is continuous in closed interval a comma b, and second condition is it is differentiable in open interval a comma b. Then there exists at least one point, excuse me, c belongs to open interval a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. Okay, so first what we have to check, so same like previous method we have to follow. First we have to check whether it is differentiable or not. So next we have to check whether it is continuous or not. So actually we are checking only differentiable because every differentiable function is continuous. So that's why I'm checking first whether the given function is differentiable or not. Okay, is it clear all of you? Same like Rolle's theorem, first of all we have to check we have to come with the backward direction. Okay, so if we have third condition, no, so we have to check whether f of a equal to b or not, but here we don't have third condition. So that's why first of all we have to check whether the given function is differentiable or not. So based on that we can directly write whether it is continuous or not. Okay, clear? Is it clear all of you?
Yes, ma'am.
Okay, give response, Amma. So what is f dash of x? Here f of x is this one. What about x, f dash of x? X cube differentiation is 3x square minus x square differentiation is 2x, and minus 5x differentiation is 5, and constant differentiation is 0. So is this polynomial or not?
yes.
Okay, so if I substitute one here, we won't get that is not equal to, right? So that means f dash of x here, f dash of x is not equal to infinity. So therefore f dash of x exists in open interval 0 comma 4. Okay, so because always differentiation will be exist in open interval only. Okay, because differentiation, in the definition of differentiation we will get only unique tangent, right? So in the endpoints we'll get more than tangents. So that's why we have to take in the open interval 0 comma 4 here. Okay, so f dash of x exists in open interval 0 comma 4 means, so f of x is differentiable. F of x is differentiable in open interval 0 comma 4, right? What about the next statement or next condition? Anyone? Yes. So directly here I am writing f of x is continuous. F of x is continuous in closed interval 0 comma 4. Why we are writing directly, therefore f of x is continuous in closed interval 0 comma 4? Because already we know that in the note we have every differentiable function is continuous. Okay, every differentiable function is continuous function, isn't it? Continuous function. So that's why directly we can write if it is differentiable, then we can write that is continuous. If it is not differentiable, no need to check whether it is continuous or not. Directly we can write that the given condition is not satisfied. So that's why the Lagrange's mean value theorem is not applicable for the function. Okay. So which function is there? You have to mention that function. Okay. So next, what we have to do, Amma? Yes, tell me. Same procedure like Rolle's mean value theorem. Yes.
F dash of C.
So now we need to find f dash of by using f dash of C, we can find C value. So we check whether the value is in between 0, 4 or not. So but before that, all the conditions. Okay. So all the conditions of the of the LMVT, Lagrange's mean value theorem, is satisfied. So by LMVT, what is the formula? By Lagrange's mean value theorem. So what is the main formula? F dash of C equal to f of B minus f of A divided by B minus A. So we know that here A value is 0 and B value is 4, right? So A is 0, which will be in the form of closed interval A comma B, right? So here A value is 0 and B value is 4. Okay. So what is f dash of X? Here we have f dash of X. Instead of X, we need to put C. Okay. So according to the this condition, directly we can write f dash of C means here 3c square minus 2c minus 5. So now we need, here we have f of X equal to, okay, the function is x cube minus x square minus 5x plus 3, right? So what we have to find f of A and f of B. Okay, so what is f of B? B is nothing but here, what is B value? B is 4. Okay, so that is nothing but f of 4, that is equal to 4 cube minus 4 square minus 5 into 4 plus 3. Okay, isn't it? So next f of A. So what is A value? A value is 0, isn't it? A value is 0 and B value is 4. Okay, now we have to substitute here, that is 0 cube. Instead of X, we have to substitute 0. So that is 0 cube minus 0 square minus 5 into 0 plus 3. Okay, so what is the value of f of B and what is the value of f of A?
31, ma'am.
So B value is 31, na? This value is 3, na? Because these are all zeros, no? We'll get only constants. So substitute all these values, this one, and this one, you have to substitute in the main formula. Okay, so then we will get, so f dash of C is, so according to this, what is f dash of C? F dash of C is 3c square minus 2c minus, what is that, 5? So this is 5 equal to, so f of B, what is f of B? F of B is 31 minus f of A is 3 divided by B value is, what is B value?
4.
B is 4. And what is A? A value is 0. A value is 0, right? So after simplification, 3c square minus 2c minus 5 equal to 7.
Yes, ma'am.
Now tell me what is the value of C. Here square is there. So here degree is 2. So that's why you will get 2 values, right? 2 roots you will get. So what about those 2 roots? If you know Rolle's theorem, no, then Lagrange's mean value theorem and Cauchy's mean value theorem will be easy. So what is the C value?
2.36 and
2.36 and
minus 1.69.
1.69.
1.69. So is this belongs to open interval A comma B, amma? Is first case is belongs to open interval 0, 4. A comma B is nothing but 0, 4, right? So is that value is belongs to open interval 0, 4? Yes. Yes, 2.636 అనేది 0,4 కి ఇన్ బిట్వీనే ఉంటుంది అంతేనా? ఇట్ విల్ బి దేర్ ఇన్ బిట్వీన్ 0,4. బట్ ఈస్ దిస్ బిలాంగ్స్ టు ఓపెన్ ఇంటర్వెల్ 0,4? So 0 to 4 are positive values, but here we are having negative value. So that's why that is not belongs to open interval a comma b or open interval 0,4, right? So at least 1 point. Here we are getting 2 points. So but in these two points, at least 1 point is belongs to open interval a comma b. So therefore, so Lagrange's mean value theorem is verified. Okay, so from this we can conclude that, okay, because it is differentiable, it is continuous, and it is belongs to open interval a comma b. C value is belongs to open interval a comma b, so that's why Lagrange's mean value theorem is verified. Okay, clear? Shall I erase my screen? Shall I wipe off the screen?
Yes, ma'am.
Yes, ma'am.
Okay, good. So I will give you one question. So all of you make a note of this question. This is important question. Verify Lagrange's mean value theorem. Mean value theorem for f of x equal to log x base e. Okay, so log x base e in closed interval 1 comma e. Closed interval 1 comma e. So what is e value, ma? What is e value?
2.3.
2 point. One second, calculator. Then tell me what is e value?
2.7182.
2.71. So that is 2.71. So the limits are here 1 comma 2.1 comma 2.71. Okay, is it clear? Now do this problem, all of you. Do it fast. Important question this is. First, what we have to check first? Here we have to check whether it is differentiable or not. Okay. So f dash of x. Log x differentiation is 1 by x. Okay. Here the limits are 1 comma 2.71. In between we don't have 0, right? So that's why this is f dash of x not equal to infinity. If I substitute any value in between 1 comma 2.1 comma 2.71, no, you don't get that value is infinity. Okay, so that's why f dash of x exists in 1 comma e, open interval 1 comma e, right? So e is nothing but 2.71. Okay, so therefore f of x is differentiable in open interval 1 comma e. So what about second step? So whether the function is continuous or not. So already we know that every differentiable function is continuous. Directly we can write f of x is continuous in closed interval a comma b or 1 comma e. Okay, so since we must write this condition, every differentiable function is continuous. Okay, so therefore all the conditions all the two conditions of Lagrange's mean value theorem satisfied. By Lagrange's mean value theorem, what is the main formula? F dash of C equal to f of B minus f of A divided by B minus A, isn't it? B minus A. Okay, clear? So what is
Yes,
f dash
ma'am.
of C? 1 by C. What is f of A? That is
0.
nothing but f of 1. So that is log 1. Log 1 is nothing but 0, isn't it? So what is f of B? That is f of E. So already we have log x base
1.
E, right? So that is nothing but log E base E.
1.
Log E base E means
1. 1.
1. Okay, so now substitute all these values here. Okay, so now we'll get f dash of C is nothing but 1 by C equal to f of B. That is 1 minus f of A, 0 divided by what is B value? B is nothing but E minus what is A value? A is nothing but 1. So what is C?
C is equals to E minus 1.
Yes,
C is equals to
E
E
minus
minus
1.
1.
E minus 1. Is this belongs to open interval 1 comma EM?
Yes, ma'am, it belongs.
Is this value belongs to? Yes, belongs to, because we know that C is nothing but, E value is nothing but 2.71 minus 1. Okay, so that is 1.71, right? So that value is belongs to 1 comma 2.71. Is it clear? So that's why C
Yes,
equal to
ma'am.
E minus 1 is belongs to 1 comma E. So therefore, Lagrange's mean value theorem is verified. Isn't it? It's most important question. Okay. So I will give you one homework problem. All of you take that question. Any doubt in this question? What happened, guys?
Ma'am, in the same question, ma'am, if the
If
limits
the
are
limits
from
are different.
limits are different from 0 to 0 comma E, so it is not differentiable. So like it is not verified.
That is
there.
totally based on the limits.
Yes, ma'am.
Okay. So you should focus on limits. Okay. So based on the limits, the problem will be changed. Okay. Now coming to, shall I erase the screen? So all of you take this question as homework. Verify Lagrange's mean value theorem for f of x equal to x into x minus 2 into x minus 3. Okay. Verify Lagrange's mean value theorem for f of x equal to x into x minus 2 into x minus 3 in 0 comma 4. Okay. So all of you do this problem. Is this polynomial or not?
Yes, ma'am.
Polynomial.
Yes, ma'am.
Yes, it is polynomial. So if it is polynomial, no, in that case, that is differentiable and continuous, right? So
Ma'am,
Lagrange's
direct గా రాసేయచ్చు కదా.
yes, direct గా అంటే?
Like it is a polynomial and polynomial form రాసి, so it is a polynomial, it is
Yes,
differentiable.
f dash of x, you need to simplify this one. From that you can find f dash of x. Okay, so f dash of x will be exist because it is polynomial, no, directly you can write. Okay, then f of x is differentiable. So if it is differentiable, then it will be continuous. So just we need to find from this formula, we have to find C value. Okay, so sometimes they will give the question like find C value by using Lagrange's mean value theorem. Is this belongs to open interval 0 comma 4 or not? So like that they will give questions. Okay, so from this we can find C value. So just you need to check whether that value is belongs to 0 comma 4. Okay, so then only Lagrange's mean value theorem will be verified. Okay, shall I have you taken this question, Amma? Have you written this question?
Yes,
Shall I
ma'am.
read the screen? Okay. Now coming to the next question. So all of you listen carefully. The most important question. If A less than B, prove that A is less than B, prove that B minus A divided by 1 plus B square is less than tan inverse B minus tan inverse A is less than B minus A divided by 1 plus A square. Using Lagrange's mean value theorem, Lagrange's mean value theorem, deduce the following. Okay, deduce the following. First question. Okay, so that is pi by 4 plus 3 by 25 is less than tan inverse 4 by 3 is less than pi by 4 plus 1 by 6. Okay, so second question is here 5 pi plus 4 divided by 20 is less than tan inverse 2 is less than pi plus 2 divided by 4. Okay, so how to do this problem? Anyone? Yes. Here, what is our question? By using Lagrange's mean value theorem. So by using Lagrange's mean value theorem means, so it satisfies all the conditions of Lagrange's mean value theorem, right? Isn't it? All the conditions means it is differentiable at open interval a comma b, and it is continuous at closed interval a comma b, and here C belongs to open interval a comma b, and it satisfies f dash of C equal to f of b minus f of a divided by b minus a, right? So all the conditions of the Rolle's theorem will satisfy, because by using Lagrange's mean value theorem means you can use those conditions. Okay, so what is our first condition? So before that, so what is the function? What is the function? Anyone, can you tell me what is our f of x?
Tan inverse B minus tan inverse A.
Tan inverse b minus tan inverse a. What is our function? Think. Otherwise, check a deduction.
Tan inverse of A
Tan
minus
inverse
B by
of
1
X.
plus A.
Yes.
Tan inverse X.
Yes, very good. Here the function is tan inverse x. Okay. So now let us consider by the question. Let us consider the function f of x equal to tan inverse x. What about the limits, Amma? What about the limits? Limits. Limits.
B
A
minus
comma B.
A to B.
Okay, a comma b. Okay, here the limits are a comma b. So consider the function f of x equal to tan inverse x in closed interval a comma b, right? Okay, so and it satisfies LMVT, Lagrange's mean value theorem, right? Isn't it? So it is differentiable. That means what is the meaning of this? It satisfies Lagrange's mean value theorem means it is differentiable and continuous. Okay. So according to our first condition, f of x is differentiable. Where it will be differentiable? In open interval a comma b. Okay. So f of x is differentiable means f dash of x exists. So where it will be exist? In open interval a comma b. Okay. So because here we are using Lagrange's mean value theorem. That means it satisfies all the conditions of Lagrange's mean value theorem. So from the first condition, we can write f of x is differentiable in open interval a comma b. Otherwise, you can write. Okay. So otherwise, you can write the first condition is f of x is continuous in closed interval a comma b. That is your wish. But the main important thing is here. So we need to find. Okay. So we need to find f dash of x because f of x is differentiable in open interval a comma b means f dash of x will be exist in open interval a comma b, right? So therefore from that f dash of x means what is f dash of x, Amma?
1 by 1 plus x square.
1 by. So tan inverse x. Okay, here f of x is tan inverse x, isn't it? F of x is tan inverse x. So f dash of x will be 1 by 1 plus x square. So the differentiation of tan inverse x is 1 by 1 plus x square. Okay, so this will be exist in open interval a comma b, right? So we know that the second condition, that is f of x is continuous in closed interval a comma b. Okay, so what is the main formula? By Lagrange's mean value theorem, the formula is f dash of c equal to f of b minus f of a divided by b minus a, isn't it? So what is f dash of c? F dash of x is nothing but tan inverse x, right? F dash of x is nothing but 1 by 1 plus x square, isn't it? So what is f dash of c?
1 by 1 plus c square.
So 1 by 1 plus c square is equal to what is f of b? F of x is tan inverse x. So from that f of b is instead of x we have to substitute b, isn't it? F of x is tan inverse x. F of b is nothing but tan inverse b. What is f of a? Tan inverse a, isn't it? So you have to substitute the values here. So this is tan inverse b minus tan inverse a divided by b minus a. Okay, so now let us consider that is equation 1. Let us consider this is equation 1. So here most important thing is, so just what is one more condition in Lagrange's mean value theorem? Any conditions unnai? It is differentiable in open interval a comma b, it is continuous in closed interval a comma b, and f dash of c equal to f of b minus f of a divided by b minus a, and the last condition is here. మర్చిపోతున్నారు ఏదో ఇక్కడ నుండి ఏం చేస్తాం ఇప్పటి వరకు ఏం చేసాం so from that we can find c value whether that c value
Exist in given interval.
How can you check whether it is existing or not? So we need to check whether c belongs to at least one point, c belongs to open interval a comma b or not, isn't it? So this total problem will be depends on this one. Okay, so here we know that the condition is c belongs to open interval a comma b, right? So c belongs to open interval a comma b means what? What is the meaning of c belongs to open interval
C is in between A and B.
means? How can you
C
write?
A is no C, A is less than C is greater than B. A is less than
C is less than B.
B.
A is less than, C is less than B. Okay, so what is so what do you need here? See, our function in between we need 1 by 1 plus x square, right?
We can take f dash on all.
No.
Adding one on
Tan
We have to
inverse on
convert.
both sides.
We have
On
to
all.
convert this one, the c value into like this. Okay, so after that you have to substitute that value here. Or
squaring.
otherwise you have to substitute the value here. So for that we have to take squaring on both sides, right?
Yes, ma'am.
A square is less than c square is less than b square. Then add plus 1 on both sides, isn't it? So we need 1 plus c square first. So for that 1 plus a square is less than 1 plus c square is less than 1 plus b square. Next what we
Inverse.
have? Inverse means
1
you
by
have to take 1 by 1 plus a square. So what about the
Greater
symbol?
than. Greater than.
Very good, very good. That is most important. Okay. So if you take inverse on both sides, now in that case, the symbol will be changed. And if you take a negative symbol on both sides, no. So in that case also, the symbol will be changed. 1 by 1 plus b square, isn't it? So now we have to substitute this 1 by 1 plus c square value. So what is the value of 1 by 1 plus c square, Amma?
Tan inverse b minus tan inverse.
From that. So from equation 1, we can write 1 by 1 plus a square is greater than. So what is the value of 1 by 1 plus c square? From equation 1, we can write that is tan inverse b minus tan inverse a divided by b minus a is greater than 1 by 1 plus b square, isn't it? Is it clear, all of you?
Yes, ma'am.
So first we need to write. So by using Lagrange's mean value theorem means it satisfies all the conditions of Lagrange's mean value theorem. So that means it is differentiable and it is continuous, and we can use the main formula, and also it satisfies C belongs to open interval A comma B. Okay, so from differentiable condition we can write f dash of x. Okay, so here f dash here f of x is nothing but from the equation we can write f dash of x. Okay, so let us consider that function is tan inverse x. Okay, so from the equation we have to assume that f of x summa. Okay, so from that that equation f of x is tan inverse x and the limits are ab. Okay, so you can take every time the limits are ab only. Okay, and from that we can write f dash of x exists, right? Because it is differentiable. So that's why f dash of x equal to tan inverse x differentiation is 1 by 1 plus c x square. Okay, so and the main formula of Lagrange's mean value theorem is f dash of c equal to f of b minus f of a divided by b minus a. Okay, so substitute all these values in the equation. So and let us consider that the equation is 1. Okay, and also we know that the main condition and one more condition is there for Lagrange's mean value theorem, and the condition is c belongs to open interval a comma b. So c belongs to open interval a comma b can be written as a is less than c is less than b. So what is the meaning of c belongs to open interval a comma b? That meaning is a less than c less than b. Okay, so we have to convert c into like this. Okay, after that we have to substitute this value over here. Okay, so for that we have to convert the c value into. So first here I am taking the squaring on both sides, then adding 1 on both sides, then taking the inverse on both sides. Okay, so if you take inverse, no, so then the symbol will be changed. Okay, if you multiply with the minus a, no, if we are having a less than c less than b, right? So if you are multiplying with minus a on both sides, no, then only the symbol will be changed. Only these two cases only the symbol will be changed. If you take 1 by a is 1 by a, then the symbol will be changed. That is 1 by c is greater than 1 by b. Okay, so after that what we have to do? Here we have to prove that b minus a divided by 1 plus b square is less than tan inverse b minus tan inverse a is less than b minus a divided by 1 by b minus a divided by 1 plus a square, right?
Multiplying by b minus a.
Yes. Okay. What is our next step? multiplying with the b minus a on both sides. So after that, this multiplying with b minus a on both sides, no, that is b minus a divided by 1 plus a square is greater than tan inverse b minus tan inverse a is greater than b minus a divided by 1 plus b square. So now which will be in the direction of like this, right? If you take in the reverse direction, no, so this will be in the reverse direction. Otherwise, you can take inverse on both sides. Okay, so that means b minus a is 1 plus b minus a divided by 1 plus b square is less than tan inverse b minus tan inverse a is less than. Next condition is b minus a divided by 1 plus a square, right? So hence we proved, right? So then think about first deduction and second deduction. So how to do these two deductions? Okay, we'll discuss in the next class. So if you have any doubt in this question, then ask me. So here the main thing is using Lagrange's mean value theorem means, so it satisfies all the conditions of the Lagrange's mean value theorem. Okay, so all the conditions of the Lagrange's mean value theorem. Okay. Any doubt? So remaining deductions we'll discuss in the next class. Okay, Amma, thank you.
Thank you, ma'am.
Closing the session.